Hello, everyone. Today we're going to talk about 5.3 rational exponents. So first I want to review a couple of concepts with you. So if I say 4 squared, you know that that's 16. And therefore you know that the square root of 16 also equals 4. Because squaring and taking square root are opposites. But what if I said that x times x to some power times x to the same power is equal to x to the first? What would be those powers? Hopefully you've come up with that would be x to the 1/2 times x to the 1/2 equals x to the first, because we know that when we're multiplying like bases, we keep the base and add the exponents. So that would give me x to the first, because x to 1/2 plus 1/2 equals 1. But we should also know that since squaring and square rooting are opposites, the square root of x times the square root of x also equals x, because that gives me the square root of x squared, which is x. So the point of this is that I can write the square root of x as x to the 1/2 power. And I can write the cube root or the fifth root or any root of x as x to the 1/3 power. So my example is 6xy to the 1/2 power in radical form. That means I'm going to take the square root of everything I'm raising to the 1/2 power. So it's square root of 6xy. Here, if I want to write 625 to the 1/4 power, well, that's equal, first of all, to the 4th root of 625. But also, if I want to simplify that, I can simplify that on my calculator. So on my calculator, oops, thought I had it open. I'm going to do 625 caret, then I'm going to do the fraction, 1/4. And that's just equal to 5. And that equals 5 because 5 times 5 times 5 times 5, 4 of them equals 625. So now I want you to write each of these in a radical form. Write each expression in radical form, or write each radical as exponent. So I want you to pause and I want you to try 1 through 9. Okay, so hopefully you tried these. So 14 to the 1/2 is the square root of 14. 5x to the 1/2 is 5 square root of x, because the only thing being raised to the 1/2 power is the x. Just like number 3 is 17 square root of y, because the only thing with the exponent of 1/2 is the y. Number 4 is the square root of 12. 5 is 19a square root of b, because the only thing with the 1/2 power is the b. Now we're going the other way. So the square root of 17 is 17 to the 1/2 power. Square root of 12n, since there's more than one thing in there, I got to use parentheses, 12n to the 1/2 power. Number 8, it's 18b to the 1/2 power. And 9 is 37 to the 1/2 power. Next, we're going to simplify. So I will show you how we can use your calculator to either do the root or to the 1/5 power. That's easy. I personally like to always do it to the fractional power. I think it's easier, but I will show you how you can do it. So to do the cube root of 343, so I'm going to open my calculator. Cube root, to find the cube root, I go to math, which is below the green button, And you'll see that option 4 is the cube root. Oops. Math, option 4 is a cube root. So I'm going to do the cube root of 343. Enter. The answer is 7. I thought there was a way that I could have them both open. There we go. So now I want to do the 5th root of 1024. So on my calculator, I can go to math and then see option 5 is the x root. So I'm going to do option 5, and then I put the 5 on the outside, arrow over, and do 1024 on the inside. And my answer is 4. So I want you to pause, and I want you to practice doing this for 12 through 18. Okay, so my answers are 13 is 7, 14 is 2, 15 is 3, 16 is 11, 17 is 9, 18 is 8. So now we're going to see how else we can use this information. So if I want to figure out what x is, I know I have 1024 to the x minus 1 equals 4. What I want to do is I want to write those both using the same base. So I'm going to try to find 1024 as a base of 4. So on my calculator, I'm going to try different things. So 4 to the 5th, oh, lucky guess, is 1024. So since 4 to the 5th equals 1024, what I can do is I'm going to take out the 1024, and I'm going to write that as 4 to the 5th in parentheses to the x minus 1 power equals 4. Now 4 with no exponent is a 1. Now our rule is when we're raising a power to a power, we're multiplying the exponents. So that's 4 to the 5 parentheses x minus 1 equals 4 to the 1st. Now that my bases are the same, I can forget about the base, and I'm just going to say the exponents are equal. So 5 parentheses x minus 1 equals 1, and I solve that. But first I distribute. 5x minus 5 equals 1. I add 5. I get 5x equals 6. Divide by 5. X equals 6/5. So now I'm going to do another one. So I have 2 to the x equals 128. So I want to write 128 as a base of 2. So I try on my calculator. So I'm going to try 2 to the 5th. Oh, that's 32. I need to go bigger. 2 to the 6th is 64. 2 to the 7th is 128. So since 2 to the 7th equals 128, I'm going to write this as 2 to the x equals 2 to the 7th. And now they have the same base. So I can just say the exponents are equal. So x equals 7. 81, I want to write as a base of 3. So 3 to the 4th power is 81. And again, I'm just kind of doing logical guess and check, estimating. So 81 is 3 to the 4th, so I take out the 81 and I replace it with 3 to the 4th. Now my bases are the same, so I'm going to set 3x plus 1 equals to 4. Subtract 1. 3x equals 3. Divide by 3. X equals 1. Okay. Number 3. I'm going to try to get 32 as a base of 4. So if I try 4 squared, I get 16. 4 cubed, 64. Uh-oh, I can't make 32 be a base of 4. Can I make 4 and 32 have the same base? And the answer to that is yes, because 2 I can write as 2 squared. So that's 2 squared to the x minus 3. And 32 is 2 to the 5th. So when I'm raising a power to a power, I multiply those exponents. So it's 2 to the 2x minus 6. I have to distribute that. Equals 2 to the 5th. Now my bases are the same. So that means 2x minus 6 equals 5. I solve by adding 6, then divide by 2, and x equals 5.5. I want you to pause the video now and try numbers 4 through 12. Okay, so on number 4, 5 to the 6th is 15,625. So that means x equals 6. Number 5, 6 cubed is 216. So then I set 3x plus 2 equal to 3. Gives me x equals 1/3. Number 6, I rewrite 16 as 4 squared, which means 5x minus 3 equals 2. Gives me x equals 1. 7, 3 to the 8 equals 65, 61. So x equals 8. Number 8, 2 to the 9th is 512. So 5x plus 4 equals 9. I solve that and I get x equals 1. Number 9, 7 to the 3rd equals 343. So that means x minus 2 equals 3. So x equals 5. Number 10, 8 to the 6th is 262, 144. So that means x equals 6. 11, 5 to the 5th is 3,125. So that means x equals 1. And number 12, 9 to the 4th equals 6,561. So I solve 2x minus 6 equals 4, which gives me x equals 5. So that is it for our video today. If you have any questions, please ask me tomorrow.